So we have the function g of x is equal to x squared times the natural log of x. And what I want to do in this video is see if we can figure out the absolute extrema for g of x. So are there x values where g takes on an absolute maximum value or an absolute minimum value? Sometimes you might call them a global maximum or a global minimum. So the first thing I like to think about is, well, what's the domain for which g is actually defined? And we know that in the natural log of x, the input into natural log, it has to be greater than 0. So the domain is all real numbers greater than 0. So x has to be greater than 0. Anything natural log of 0 is not defined. There is no power that you could take e2 to get to 0, and natural log of negative numbers is not defined. So that is the domain. The domain is all real numbers such that all real numbers x such that x is greater than 0. So our absolute extrema have to be within that domain. So to find these, let's see if we can find some local extrema and see if any of them are good candidates for absolute extrema. And we could find our local extrema by looking at critical points or critical values. So let's take the derivative of g. So g prime, I'm just in a new color just for kicks. All right, so g prime of x is equal to, we could use the product rule here. So derivative of x squared, which is 2x, times the natural log of x, plus x squared times the derivative of natural log of x, so that is 1 over x. And I can just rewrite that x squared times 1 over x, and we're going to assume that x is positive. So that is going to be just, and actually I didn't even have to make that assumption for what I'm about to do. X squared divided by x is just going to be x. All right, and so that is g prime. So now let's think about the critical points. Critical points are where the derivative, they're points in the domain, so they're going to have to satisfy x is greater than 0, such that g prime is either undefined or it is equal to 0. So let's first think about when g prime is equal to 0. So let's set it equal to 0. 2x natural log of x plus x is equal to 0. Well, we could subtract x from both sides of that. And so we get 2x natural log of x is equal to negative x. Let's see, if we divide both sides by x, and we can do that, we know x isn't going to be 0. Our domain is x is greater than 0. So this is going to be, actually let's divide both sides by 2x. So then we get the natural log of x is equal to negative 1/2. Negative x divided by 2x is negative 1/2. Or we could say that x is equal to e to the negative 1/2 is equal to x. Remember, natural log is just log base e. So e to the negative 1/2, which we could also write like that, e to the negative 1/2, or 1 over the square root of e. So that's a point at which our derivative, I should say, is equal to 0. It is a critical point or critical value for our original function g. So, and that's the only place where g prime is equal to 0. Are there any other points where g prime is undefined? And there have to be points within the domain. So let's see, what would make this undefined? The 2x and the x, that you can evaluate for any x. Natural log of x, once again, is only going to be defined for x greater than 0. But we've already restricted ourselves to that domain. So within the domain, any point in the domain, our derivative is actually going to be defined. So given that, let's see what's happening on either side of this critical point. And I could draw a little number line here to really help us visualize this. So if this is negative 1, this is 0, this is, let's see, this is going to be like 1 over, oh boy, this is going to be a little bit less than 1. So let's see, let me plot 1 here and then 2 here. And so we have a critical point at 1 over the square root of e. So let me put it right over there. 1 over the square root of e. And we know that we're only defined for all x is greater than 0. So let's think about the interval between 0 and this critical point right over here. So the open interval from 0 to 1 over the square root of e. Let's think about whether g prime is positive or negative there. And then let's think about it for x greater than 1 over the square root of e. So that's the interval from 1 over square root of e to infinity. So over that yellow interval, well, let's just try out a value that is in there. So let's just try g prime of, I don't know, let's try g prime of 0.1. Z prime of 0.1 is definitely going to be in this interval. And so it's going to be equal to 2 times 0.1 is equal to 0.2 times the natural log of 0.1 plus 0.1. And let's see, this right over here, this is going to be a negative value. In fact, it's going to be it's definitely going to be greater than -1, because e to the -1 only gets you to, let's see, e to the -1 is 1 over e, so that's 1 over 2.7. So 1 over 2.7 is going to be, so this is going to be around 0.3 or 0.4. So in order to get 0.1, so this will be around 0.3 to 0.4. So in order to get to 0.1, you have to be even more negative. So this is going to be, I guess you could say, less than -1. So if this is less than -1 and I'm multiplying it times 0.2, I'm going to get a negative value that is less than -0.2. And if I'm adding 0.1 to it, well, I'm still going to get a negative value. So over this yellow interval, g prime of x is less than 0. And it would be, I should have gotten a calculator, or I could have gotten a calculator out. I could have just evaluated a lot easier. So g prime of x is less than 0 in this interval. And let's see in this blue interval what's going on. And this will be easier. We could just try out the value 1. So g prime of 1 is equal to 2 times the natural log of 1 plus 1. Natural log of 1 is just 0. So all of this just simplifies to 1. So over this blue interval, I sampled a point there. G prime of x is greater than 0. So it looks like our function is decreasing from 0 to 1 over square root of e, and then we increase after that. And we increase for all x's that are greater than 1 over the square root of e. And so our function is going to hit, if we're decreasing into that and then increasing after that, we're hitting a global minimum point, or an absolute minimum point at x equals 1 over the square root of e. So let me write this down. We hit a absolute minimum at x equals 1 over the square root of e, and there is no absolute maximum. As we get above 1 over the square root of e, we are just going to think about what's going to be happening here. We're just going to, we know that our function just keeps on increasing and increasing and increasing forever. And you could look at even this. X squared is just going to get unbounded towards infinity, and natural log of x is going to grow slower than x squared, but it's still going to go unbounded towards infinity. So there's no global or no absolute maximum. No absolute maximum point. And now let's look at the graph of this to feel good about what we just did analytically without looking at it graphically. And I looked at it ahead of time. So let me copy and paste it. And so this is the graph of our function. So as we can see, when this point right over here, this is when this is 1 over the square root of e. It's not obvious from looking at it that it's that point. X equals 1 over the square root of e. And we can see that it is indeed an absolute minimum point here, and there is no absolute maximum point. There's arbitrarily high values that our function can take on.